In the last video, we said that pass by reference is more efficient way of passing parameters than pass by value. And I didn't really say exactly why. The reason actually is that when you use call by value, you require that a copy be made for the function call itself, and this gives us overhead. So I'll set up a very simple example. The reason for using pass by references when you have large classes, when you pass in large objects, so especially for large data, call by reference becomes especially handy. Now we will just use a very tiny example. We'll just use the XYZ class. So let's take a look at that. What I've done is I've set up this new add function which takes as parameter an XYZ object. And so this looks just like call by value. It's just like saying an int parameter, int x. And so I say XYZ, name of the class, and the name of the parameter inside the function. Let's take a look at what this function does. All it does is it takes the x data member of this other object, adds it to x, and stores that in the x data member of the current object. It does the same thing for y. So it's just adding the x data members of the other object and the current object, storing that in the current object. Same thing for y. Okay, so if you run this, it won't take that long to run. So you won't be able to notice because this is such a tiny object. It's just got an int and a double, so it's not that cumbersome to use, or it's not that inefficient. Okay, so the other thing that I've done to show that a copy is made, and let me just bring this up again. The whole problem is this. If you use call by value like we're doing in this add function, we end up using call by value. And what ends up happening is that behind the scenes, C++ generates a copy just like it would for an int parameter or a float parameter, things like that. So it does it sort of in a dumb way. And we want to be a little bit more smart. We don't want to make an entire copy of this object. Oops. I hit the wrong thing. Alright, so to illustrate this, what I've done is I've set up a copy constructor, and that's what this thing is. So it looks like, unlike usual constructors, it's got a constructor, it's got the name of the class, and it's got a call by reference. So this is actually call by reference, and that's what copy constructors are meant to be. That's how they're meant to be set up. Okay, so I'm just putting it in to show you that this is going to get called. And we'll talk about copy constructors in a lot more detail. And here's a simple example of a copy constructor. So you pass in sort of a source object, and then you just copy the data members of that source object into your data members. So x gets the same value of the x data member of the source object, and the same thing for y. So let me just close this. All right, opened something by mistake. Okay, so here's your copy constructor, and what we want to do is show that this is called in this simple use of add. So nowhere in here do we explicitly call the copy constructor, but I want to show you is that when you call this add function, and what this is supposed to do is take the x data member of y, that is 5, add it to the 3 and store that in x. It takes the y data member 1.23 of this y object and adds it to 5.45, stores it in x. So after this add is done, let's take a look at the add function again. You should have the current value plus the value of the other thing. So when you do this, you should have current value 3 plus the value of the other thing, which is 8. So that should go into data member x of this x object, and 1.23 will be added to 5.45 and stored in the y data member of object x. So when we run this, it should say X has data member 8. That's 5 plus 3. Okay, let's compile this. Very simple change. And when you run this, it says X has data member 8. So how did it get that? It says X has data member, and it's just getting the X value, which was 3, but then we added the X data member of Y, and so 5 plus 3 gave us 8. Okay, I'm hoping that's okay. This is all supposed to be really straightforward. Now what I'm going to do, this is where I show you that you actually end up creating a copy of Y. So I'm going to say cout. So remember, I did say that you never want to put couts in your classes. Try to avoid it, but this is debugging. We're trying to figure out what's going on, and so for debugging this is okay. So we're going to say copy constructor call. Okay, that's it. And we want to end line. Okay, so here's another reason why we don't want couts, is because you have to import this. You have to pound include IO stream. Okay, once you do that, you get all these names, and then if you using namespace standard, now you're importing all the names. It gets messy. So in this particular case, you might say, look, I really don't want to use all of the names in the standard namespace because there's a lot of them. I just want to use cout, and from the standard namespace, I want to use endline. That's it. That's all I need. And now, but I still do have to pound include IOStream, and you can put it here between function definitions. That's okay. So you want to avoid this. That's why we don't want to have couts in our classes as much as possible. Sometimes it's necessary. Let's say you need to open up files. Yeah, then you would need these. But if you don't need it, it's better not to have it. This we're doing to debug. Okay. So note that first time around when we ran this, we got just 2 lines of output. So we got constructors for classes. That's the first thing that we print in our main, and then we print out X has data member, and in this case we got the answer Y. Okay, so we only have 2 couts. We have one more cout in the copy constructor. Thing to note is we do not call the copy constructor explicitly anywhere, but what I want to show you is that when you call this using call by value, you are calling the copy constructor, and that's a huge overhead, or can be a huge overhead when your classes are much bigger. Let's say they have a JPEG image with 10 megabytes. You want to create a complete copy of that JPEG image. That's tremendously inefficient. That's going to be a huge overhead. Okay, so compiled it, and now we run it, and lo and behold, we have that extra line. It says copy constructor called. So what is this saying? This is saying that when we use this add function, we end up calling the copy constructor. That is, we make a complete copy of this object Y, and then that's what we pass into the add function. So although it looks really harmless, you say add some other object. This can be tremendously inefficient if these objects were big, like if it had a huge JPEG image, something like that. Okay, so what's the fix? The fix is to use call by reference. And that's actually why the copy constructor uses call by reference. So what do we do? To avoid calling the copy constructor, we say pass this by reference, and we have to make the same change in the .cpp file. Okay, save both of these. Save this. Save this. Errors go away. Compile it. Shouldn't get any errors. And now the difference is when you run it, you should not call the copy constructor. Okay, so run it, and lo and behold, no copy constructor called. Everything is a lot more efficient. So this is just an illustration of this claim that we made, that call by reference or pass by reference is more efficient, as a more efficient way of passing parameters than call by value. Also, you want to note that we said that in Java we always use call by value. Well, that's true for primitive data types. It turns out even though we don't have an explicit call by reference mechanism in Java, so we don't have to put this ampersand symbol for any of the parameters. If you are passing objects as parameters, it turns out Java actually does use call by reference. So that's all behind the scenes, and it's done automatically. You don't have a choice. So Java does this for the same reasons it's done in C++, only it makes it implicit, and so it's done by default. You don't have to worry about efficiency problems in Java. In C++ you do. You have to worry if you're calling by value or by reference. Okay, so what do you do if you're passing in something by reference? Remember that when you pass something by reference, the function can change values inside that object. So if you're passing an int and you're calling an int x by reference, you have to worry about that value in that int x changing inside the function. To fix that, we saw that we can use the const parameter modifier, and that's what we're actually supposed to do almost any time you pass by reference. So here what you want to do is you want to say const xyz. Actually, you're supposed to do the same thing for the copy constructor. We haven't talked about the copy constructor. It was here just to illustrate that it does get called. And we'll talk about the copy constructor later. So let's save this and make the corresponding changes here. We have to say that this is a const. It's unfortunately, if you have the definition in the .cpp file separate from the declaration in the .h file, you have to change both of them. If you don't, you will get the compiler will give you an error message. So now we've made these things const, and it won't change our code. So everything compiles just like before. Everything will run just like before. But what it does do is it prevents you from doing something like this. Other dot x is equal to 0. So you can no longer do this. If you try it, save it, compile it, you get an error message. So what is this const doing? It's preventing you from making changes to parameters, which is an extremely useful thing to do. And in general, I would say make everything const. Any parameter, unless, you should always try to make everything const unless you actually need to change the values. So for example, these things, you might want to make these const, and so on. If at all possible, make all parameter values const. Okay, so this const doesn't make things more efficient. What it does is make things safer. So if you're passing in large data types, like say classes, it's often desirable for efficiency to have them be passed by a reference rather than passed by value, because you're not going to make a complete copy. And so to protect these arguments that are passed by a reference, we use the const modifier. So this is called constant call by reference parameter. That's what you pretty much always want to use whenever you call a function with objects as parameters. All you have to do is put the const before the type, and it makes the parameter read-only. If you try to modify the parameter, you get a compiler error, and that's protecting you against making unwanted changes.